till now we discussed AOP, aspect oriented programming, without annotations. Now how to enable aspect J annotation support in Sprint using annotations. See, if you want to use annotations, the first thing you have to do is to write this tag AOP colon aspect J auto proxy. You have to import this namespace AOP namespace and then write this tag. So this internally will actually register auto proxy creator. Just like these are two auto proxy creators, B name auto proxy creator and default advisor auto proxy creator vice versa. Just like this too, there is another thing called annotation aware aspect J auto proxy creator. Means annotation aware, it will recognize the annotations. Now once you do this, these are the 5 types of annotations available. Before annotation, after returning, after throwing, around. Before is same like before advice. After, what is the difference between after returning and after? Yeah.
And only for logger we make use of after. There is no return or leaving. After method.
Yes. One thing is, this will be executed only if the method returns successfully. If the method does not return successfully, if it throws an exception, this will not be executed. But this will be executed whether method throws an exception or not. Of course, yes, finally. And after throwing will be executed. If you annotate with after throwing, it will be executed only when exception is being thrown. Around is same like around advice. Now let us see how to use them. Just write a class. Your class need not implement any interfaces like earlier. Just annotate it with aspect. And this is the method. On top of the method, we can write any method. On top of the method, you have to annotate it with before, and you have to specify the point cut expression. Then that's all. Simply register this bean inside your XML. That's all. If you request for calculator, automatically, if any method calculator is matching this pointer, automatically a proxy will be created and given to you. Right? First, let us do this one example, and we can use the same thing for all the other annotations also. Now I'll create a new project quickly. AOP using annotations. I will copy the calculator class as earlier. Both calculator IMPL and arithmetic calculator. And I'll make the package as com.sapient. Okay, now I want to write advice. I'll create a class logging aspect. What is difference between advice and an aspect? What is difference between advice and an aspect? Yes, aspect is point cut plus advice. So now when you are using annotations, as I have shown in the PPT, here we are defining advice. This is advice what you want to give, and you are giving the point cut also. So this is called as an aspect. This class is an aspect now. Okay, now it need not implement any specific interfaces. Just annotate it with aspect. And you can write any method public void log before I'll say the method name can be anything. I'll say system.out.println before. Now I need to annotate it with before annotation. And specify the point cut. Execution of star for the return type, star for the class, dot star for all the methods, dot for all parameters. So this will be matching all the methods for now. That's it. We have defined a simple before aspect. Now we have to configure this in XML. I'll create a new XML. AOP, alright. And see here, we will be using AOP namespace. So select the AOP namespace and select the latest one. Finish. Now the first thing we have to do to enable aspect J annotation is AOP colon aspect J auto proxy. Then I will add that bin logging aspect and also calculator. Then again another wheel for logging aspect. That's it. Do I need to do anything else? No, because this will register auto proxy creator aspect annotation over aspect J auto proxy creator, which will recognize these annotations present in logging aspect. So once the annotations are read, it understands where to apply what and when, nothing else. Now in demo, if I just get a bean called calci, my advice will be applied. I will copy the demo from here. Yep, see, now the XML file name is aop.xml. The bean name is calci only. So now if I run it, both the methods should be applied. See, for both the methods, before and before was printed. This thing, am I able to access the method details? Earlier when I was implementing interfaces, this method was taking method object, parameters object and target object. So I was able to print the method name here earlier. But when using annotations, this method can be anything, right? So how to access the method details? To access the method details, what you can do like this. You can make your method to take a parameter called join point, and by using this join point, you can get all the details of that join point. Join point means method is nothing but a join point. You can get the signature of the method, get signature or get name will give you the method name, and join point dot get args will give you the arguments for that method as an array, right? Next. Now if you want to write after advice, you just have to write a method and annotate it with after, just like it. Now can I use same class for both before and after? Yes. See here, I will write a method in the same thing. Public void log after. I will make it to take join point. And I will annotate it with after. And same point cut. After means it will be executed whether the method returns successfully or not, both. Now I will say system.out.println. After executing plus the method name I want to print join points dot get signature okay then join point
Actually, that is using the org.aspect.
yeah aspect yeah I imported a different one aspect then join point dot get signature dot get name. You can get the modifiers everything. I'll just say get name and you can get the arguments also. Now this has to be applied after executing. Let me run it. Let's see, before and after, right? Before subtract, after. Similarly, I can annotate a method with after returning. After returning is same as after return, but this will be executed only after successful execution of the method. If the method throws exception, this will not be executed, right? See here, after returning, same. When using after returning, this will be executed after the method returns successfully. So you should be able to access the return value. To access the return value, what you can do is in the annotation after returning, you can use like this. You can specify the point cut is equal to and return is equal to. You can give the string. Whatever you give string here, that has to be the parameter name inside this method. By using that, you can access the result. Let us try the same thing and try to access the result. Okay, now let us try to use after returning and try to print the result of the execution. In after returning annotation, I can do like this. There are two parameters for this. One is point cut. Point cut is equal to same point cut, which will be matching everything, comma returning is equals to, I can specify anything, or I'll say result. Then the another parameter for this method can be object result. Now I'll say I'll print the return value plus return value is plus return value. Now I will execute. See, the return value is printed, right? So that's about after returning. Next topic. Next thing. Throws. We're coming here. After throwing. If you annotate a method with after throwing, this will be executed when exception is thrown. Right? And in this method, see previously in this method this will be executed when exception is thrown, but you are not able to access the exception object. If you want the exception object to be available, then you can do like this. This is a pointer and throwing. Whatever you give the value, that should be same as a variable name and it should be of text probable. Then you will be able to access the exception which caused this to be executed. Right? Now see here, the parameter type is throwable, right? This will be executed. Whatever exception might happen, this will be executed. But if you want only for this to be executed for any specific exception, then you can specify that specific exception type here. This will be executed only for this type of exception or subtypes. This type or subtypes. Okay, around advice. Around advice, you have to annotate it with around annotation, and this method should take the preceding join point as parameter should take. And now join point object dot proceed will actually call the target method. Before this you are writing some logic, after this you are writing some logic, in the catch block you are writing some logic. Same, but only the difference is this method should take join point as parameter. By accessing the join point you can get everything, right? What is the method name, what are the return types, everything. Return type anyway, and you know whenever you call join point at proceed, whatever it is returning is return value. Right? This will act like both all the types of advisors. Okay. Now, suppose we have two aspects. One is the logging aspect like earlier, right? Another aspect I am writing calculator validation aspect. These are something with aspect. So there are two aspect classes. What is the order of execution? Again, right? This is matching all the methods of arithmetic calculator. That's also matching all the methods of arithmetic calculator, right? And this is annotated with before. There is a method which is annotated with before. What is the order? There is a confusion, right? So if you want to specify the order, then you have to make your aspect class to implement ordered interface, and you should give the method get order return the value. Lowest the order value, highest will be the precedence, right? So whenever you call a method on calculator, now first validation aspect will be executed, whatever is present, then logging aspect will be executed because this is higher, right? Or the lowest the value, highest will be the precedence. So first this will be executed because this is 0. This will be executed next. Or if you don't want your aspect to be implementing any interfaces, you can use annotation also like this order of 0, order of 1 in this aspects. Okay, reusing the point cut definitions. On the top of every method, I am defining a point cut. See here, in my aspect, I have 3 methods. On all the 3 methods, am I defining the same point cut? Yes. So tomorrow if the requirement changes and I want to change my point cut, I will mapping to be only subtract method. So and how many places I need to change? 1, 2, 3 places I need to change, right? In order to avoid the redundancy, we have to reuse a point cut definition, right? So how to reuse a point cut definition? See here. Write a dummy method with any name, dummy method. On the top of it, annotate it with point cut annotation. Give your expression. And on all the other methods, what you can do is you can specify this method name. Here also method name. So if tomorrow my point cut definition has to change, I can change only at a particular location. Now here we are reusing the point cut definition. Just check. Next, centralizing the point cuts. What I can do is, I can write a separate class. In our application there can be a lot of point cuts. I can write a separate class and write one method for each point cut. This is a separate class. It's right now having only one method with this point cut. I can have another 2-3 methods, each annotated with a different point cut annotation, right? And now I want this point cut to be applied on a particular method in another class. This is another class, aspect annotated with aspect. Here on top of before I am using calculator point cut, the class name dot logging operation. So it will be applied here. So what we generally do is, in our application we will keep all the point cut definition in a central location, a single class, and we will reuse all the same point cuts everywhere. So tomorrow if I want to change a point cut, I can just directly go to this file and modify whatever point cuts I want, instead of referring to many files. Okay, as I told, aspect J expressions, execution of return type can be anything. This is a class, whole qualified class name. If you are using XML, in XML if you are defining this point cut, you have to give the qualified name. But using annotations, if you are defining, if both of them are in the same package, this point cut, this aspect class is in the same package as the target class, arithmetic calculator, you can avoid the package name. That is the advantage, right? And here also we are avoiding the package name because arithmetic calculator is in the same package as the aspect class. Saying like we thought, this will map to any method, any public method whose return type is double, is present in arithmetic calculator, present any argument. I've seen this. Same. Any method in arithmetic calculator class whose return type is double public and is taking two parameters, double comma double. Within, we have already seen this, right? And we can combine two point cuts by using OR operations. OR operations. See here in this example, this is a method which is annotated with one point cut. This is one point cut. 2 point cut methods. This is the actual method where I am combining 2 point cuts by using OR operation. Whether this expression is satisfied or this expression is satisfied.
On this I can also give that
in Java, is multiple inheritance supported? Multiple inheritance of interfaces is supported, but classes is not supported. By using introduction provided by Spring AOP, you can simulate the feeling that one class extends more than one class. Let us see with an example. It allows your objects to implement an interface dynamically, providing an implementation. Okay, let us see with an example instead of reading the theory. I have a class called an interface called max calculator, which is having a method called max, another interface called min calculator, and I am having implementation of some implementations, right? Now I want my calculator class. In my calculator class, I want to introduce these methods through AOP. Actually, in arithmetic calculator class, these methods are not present. But through AOP, I want to introduce these methods. It is like it's similar to saying that your arithmetic class is extending both max calculator and min calculator. If your arithmetic class extends both max calculator and min calculator, your arithmetic calculator will be having both min method and max method, right? So now by using AOP, I want to simulate this thing. I want my arithmetic calculator to have both. See how I'll be doing. Write an aspect and declare two variables, make max calculator, min calculator, and declare use annotations, declare parents. Default implementation. This is interface type. Default implementation is this one. And this is interface type. Default. Right? If you do like this, define your calculator instruction class inside your XML, then context.getBean arithmetic calculator. This I am asking only for arithmetic calculator, but now I will be getting a proxy, right? But the client will be feeling that he is actually working on arithmetic calculator object only. He is actually getting a proxy. Now I typecasted this proxy to max calculator and I am calling max method. The client feels that I am calling max method on arithmetic calculator object only, and I am typecasting same arithmetic calculator, I am typecasting it to min calculator and implementing. Guess how it might be working internally?
Between proxy which might implement both the interfaces.
Yes. Whenever we ask for an arithmetic calculator, we are not getting actually arithmetic calculator. We are getting a proxy to arithmetic calculator. That proxy is implementing three interfaces: arithmetic calculator interface, min calculator interface, max calculator interface. Right? Whenever you are calling this method max, that method implementation is already present inside the proxy. That will be invoked. So this is how you can get a feeling, the client will get a feeling that he is actually invoking a max method arithmetic calculator now. Right? Now. Here you just have to tell what is the parent class and what is the implementation. Implementation, default implementation tells whenever a client calls method on the proxy, which implementation has to be invoked. And into which class, whenever I request for arithmetic calculator IMPL, I should get a proxy with this also. That is the meaning of parent variable. Okay. Now I'll create a new interface, max calculator. Public int max, which this is interface, right? So max, which will take int I comma int j. Similarly, I'll write a new interface, min calculator, which will have a method min. Now, in the same aspect, I will declare a variable private min calculator on the top of it. I will declare parents. Value is equals to to which class the proxy should be it should be done. Com dot sapient dot arithmetic calculator. Comma default implementation is equals to com dot sapient dot, I didn't write implementation for now. Okay, I will write one of the implementation for these two interfaces. I will write max calculator IMPL class implements max calculator. Oh, max calculator is having both. Oh, I should write this inside. Calculator. Here I'll just write logging statement. I'm not interested in implementation. In max. Similarly, I will write an implementation for min calculator. Implements min calculator. Here also I will write a statement. Okay, now coming to this aspect, I'll say default implementation is com.sapient dot copy paste class name. Okay, default implementation I have to give it as dot classify. Similarly, I'll create a variable max calculator. On the top of it, I will annotate it with declare parents. This is max calculator IMPL dot class. That's it. Now I will be able to cast my proxy to either min calculator and max calculator and use the both. I already wrote the code in demo for getting the calc and called add method and subtract method. Now I will typecast this calc to min calculator. Then I'll call min calculator dot min and pass some values. Now it should execute min method. Let's see in min. So I got a proxy which is implementing three interfaces now: arithmetic calculator, min calculator, and max calculator. When I'm calling min, that proxy is actually calling min calculator impl dot min accordingly. Now let us see aspects in XML. Till now we saw by implementing interfaces and by using annotations. Now I don't want to implement AOP specific interfaces. I don't want to use annotations also. I want to write a simple Java class, and I want to make that as an aspect by using XML. Let us see. Yeah. See here, you can write a normal class, calculator logging aspect. This logging aspect need not have aspect annotation, need not have before annotation, after annotation, nothing. A normal Java class with some methods, log before, log after. I declared this. There are three aspects which I declared. Okay, let us consider only one. Remember, forget about these two, right? Then what I can do is I can specify AOP colon aspect reference is equals to logging aspect. So now I am telling that this is an aspect, right? Then this AOP colon aspect tag says that will make that this bean as an aspect, but again we need to tell which method inside that has to be executed when, right? See, now this is not sufficient. This only is not sufficient. See here, AOP colon aspect logging aspect reference is equals to the same bean, but now I specify AOP colon before, which is a method, log before is a method. What is the point cut reference? Point cut reference is what I specified here. AOP colon point cut, the name of the point cut and expression. This is under point cut, expression, point cut expression. So I defined point cut and gave IDs to them. And then for before point cut, for AOP colon before, what is the method to be invoked before? This is the method. And what is the point cut? This is the one. For after turning, this is the one. For after turning, this is the one. Let us write one example on the same. Okay, to be very clear, I'll just create a new project, AOP using XML. A new project, AOP using XML. Then here also I'll copy paste. First I'll create a package com.sapient. And I'll copy paste my calculator, arithmetic calculator and arithmetic calculator IMPL. And also I'll copy paste my logging aspect. I will remove all these annotations and make this plain. See, now this class is just a simple poser with some methods. Now I want to make this class as an aspect. Okay, coming to XML, we first complete this. I'm going to write an XML new AOP using XML. I select this AOP colon. Then first thing, I will define AOP colon config, AOP configuration, and here I'll configure AOP colon point cut first. ID is equals to logging point cut. I'll say any name you can give. expression is equals to execution of star space star dot star of dot dot. This is a point cut, simple point cut. Okay, then after this I will write AOP colon aspect. Before this I will declare a bean also here for calculator. Bean id is equals to calc, class is equals to arithmetic calc id. Okay, now here also I should declare the bean for logging aspect. Once I do like this, id is equals to my log aspect, reference is equals to logging aspect, and AOP before I'll say method is equals to log. Point cut is equals to point cut ref is equals to logging point. That's it. So I declared this logging aspect as an aspect, and this is a method which should be executed, and this is the point. So now if I just simply request for a calc bin, I'll get this automatically. First I will quickly copy the demo also from the earlier one. And call the add method. Now let us see whether before advice will be executed or not. What is it? AOP using XML. Yep, see, before is executed. Okay, copy this configuration. So we saw AOP using interfaces, implementing interfaces, using annotations and using. So we completed AOP topic.